topic of this presentation is Elixir programming language. My name is Teemu Harju. I come from Helsinki, Finland. And I'm really excited to be presenting you a topic that's kind of really close to my heart, Elixir. I've been programming servers for several years. Most of that I've been programming Erlang. And let's say last couple of years I've been working more and more with Elixir. And currently I work at a company called Futurefly. We make mobile apps with a bit of hint of gaming in them. We are some gaming veterans from companies like EA, Remedy, Sulake. And I can't tell too much about what we're working on now, but our next product will be a chat application combining avatars, animations, emojis, hashtags and stuff. So it will be awesome and hopefully available early next year. Okay, we've talked today about several different programming languages, functional languages, and Elixir, of course, being a functional language, shares the same concept. So you probably recognize some stuff from earlier presentations, especially from Haskell and Clojure. But still, kind of like question to ask, why another language? And I kind of want to point out some specific features that are really core to Elixir and maybe are not that well implemented in other languages. So the first thing comes to mind about Elixir is concurrency. You might know that Elixir runs on top of Erlang VM, and it's a virtual machine that has been built ground up to support concurrency, and concurrency at a massive scale. So it's been used in a telco systems for decades, and it's kind of finally making its way to like some sort of popularity, maybe with the help of Elixir. Fault tolerance is definitely something very core to Elixir. Yes, again, due to Erlang virtual machine, since Elixir gets all the benefit from the stuff implemented there. I've been programming Erlang for several years, and every time that I talk about Elixir, I tend to go comparing, like when I talk about Elixir, I'm just kind of like pointing failures in Erlang. I try to avoid this. In this presentation, I try to present Elixir as well as possible, and try not to bash Erlang. But I apologize if I do that. I really like Erlang. Elixir is really multi-core aware. So when you write software, you don't have to basically care anything or take into focus about things, considering running it on multiple cores. You just launch the application. It doesn't matter how many cores you have, it will use all of it. Built-in clustering. This is also something that comes from Erlang. So you can write your software running on a single node, and basically only a configuration change to be able to run it in a sort of fully connected cluster. That's kind of in theory, let's say. Elixir is a functional language, and in my opinion, one of the most the easiest one to pick up. It has quite friendly syntax compared to many other functional languages. It resembles quite a lot Ruby, and kind of the whole community is all about like code readability and good documentation and this kind of stuff. So if you want to like try different programming paradigms and go and look functional programming, I think Elixir is a perfect place to start, and it's quite easy to get started with. Elixir has insanely good macro support. I won't discuss that too much in this presentation. It's kind of a topic of its own, but most of the language constructs even are built using Elixir's own macro system, and it's really impressive. Elixir has an awesome tool chain, so yeah, it's always easy to say it's the best I've ever seen in any language. I guess everybody says that, but it's really good, and of course it helps that it's kind of had kind of the learnings, all the failures of the other implementations. So, but it's really good. Some people compare. I'm not too familiar with Go, but everybody I've been talking to says that it's at least as good as the toolchain in Go. And the last point, Elixir has awesome community, really helpful. It might be due to the fact that it's really small, but anyways, it's if you have questions, there are lots of people eager to answer your problems, and it kind of helps a lot in kind of getting into the programming with Elixir. Yeah, like the kind of the topic of the presentation already indicated, Elixir is a fairly new language. The 1.0 release was in September 2014. The latest stable release came out September this year. There are more than 300 contributors for the Elixir project on GitHub. And the language has been created by Jose Valim, who is one of the core developers of Ruby language, and that's kind of natural. So Elixir, especially the syntax, borrows a lot from Ruby. I'm kind of dividing the presentation into these three sections. I first talk about the language, so the basic language constructs, and discuss about like functional programming in Elixir and kind of what kind of problems you might face when you start writing functional code using Elixir. Then I want to definitely talk about the concurrency model, as well as the fault tolerance features, which are really kind of the features that differentiate Elixir from other programming languages. Yeah, so Elixir is, like probably said already 10 times, Elixir is a functional programming language. All those points apply to all functional programming languages. There are no side effects, absolutely no shared state. All the data is immutable, and the whole programming paradigm is about functions that are used to transform data. So very different paradigm from compared to object-oriented programming. And yeah, I've been, like I said, I've been mostly programming servers, or like pretty much 100%. So I think functional programming really well applies to like server-side programming. Okay, so this is pretty basic stuff. Basic types we have in Elixir. We have integers, floats, booleans, strings, ranges, all this stuff. Probably the one to want to discuss about a bit more is the atom, which is probably not that familiar data type. So atoms are constants, where basically their name is their value, and they are used quite heavily in Elixir. So basically, most common place is as a return value from a function. So, for example, a function, everything goes well in a function, it might return atom OK, or if something fails, it returns atom error. And yeah, thing about strings, they are UTF-8 encoded binaries, and so Elixir has full Unicode support, like any modern language nowadays should have. About collection types used in Elixir, we have tuples, we have lists, we have maps, and we have binaries. Again, pretty straightforward stuff. Probably the not so common data type binary. It kind of comes from Erlang side. Erlang being built for telco systems. They don't use HTTP there, so every message is binary. So kind of handling binary messages is very well supported in Erlang and as well as in Elixir. So this, for example, here can be a kind of a stream of bytes or bits. A bit about lists and tuples. They kind of, to outside they look pretty much the same. But yeah, I guess this is very common for functional programming languages. Lists are implemented as linked lists, which basically means that accessing any other element of the list except of the head of the list is linear operation, and updates are fast only if you're prepending the list. So in many cases, it's if you want to append to a list, it's done so that you prepend and then reverse the entire list. Tuples, they are stored contiguously in memory. Accessing elements in a tuple is fast, but updating is slow because you need to copy the entire tuple. There's not much special stuff here. Basic operators supported in Elixir, arithmetic, list manipulation, so you can add and deduct lists, string concatenation, Boolean operations, comparison operations, very basic stuff for dynamic languages. Yeah, do you have a question? Yeah. It has bitwise operators, and like I mentioned about the binaries, kind of handling binaries are usually done using pattern matching and stuff. But yeah, it has also bitwise operators. But these are kind of like, let's say, basic operators. You have to if you're using bitwise operators, you have to import them kind of specially. But yeah. But like I don't have actually example. It's not maybe so interesting, but kind of one of the coolest things is in Elixir or Erlang is how it handles binaries with pattern matching. So it's very different from other more imperative programming languages. Okay, so we get to the pattern matching, which I think is the if I program with a language that doesn't support pattern matching, I'm kind of like completely lost. it feels like so natural way to program. And in Elixir, the equals operator, it's actually called the match operator. So on the first line here, it's basic variable assignment. So we assign integer 1 into variable x. On the next line, that basically is an assertion that x is 1. If x is anything else than 1, it raises match error. So this is kind of the simplest form of pattern matching in Elixir. Like we've seen already today in other examples, the pattern match operator can be used for kind of destructuring more complex data structures. So here we have a tuple with integer, atom, and a string, and we can destruct them into separate variables. And we are again asserting here that they are these values here. Still more about pattern matching. It's really core concept, and it's used widely, pretty much everywhere in programming Elixir. You can pattern match the head and the tail of a list using just like a pipe operator or a vertical bar character. And you can also use the same operator for prepending the items on a list. So here we have a list of integers, and with this operator we separate kind of the head from tail. And here we assert, so head is 1, tail is the rest of the list. And this is kind of the only operational list that is fast. This is how we can prepend items on a list. So we use the same operator, but we prepend there. And this is somewhat specific to Elixir. So you can rebind a value to a variable. So some functional programming languages like Erlang does single assignment on variables. So this wouldn't be possible. Let's say we have the same variable name here, the list. And since if I did it, I wouldn't have this pin operator here in the beginning. I would be assigning this list to this variable. But if I use this pin operator, it's a pattern match. So it means that these both are equal. So this is not assigning that list to this variable. It's matching that they are equal. Yeah. Basic control flow structures. So here we start using the pattern matching kind of in real programming. So let's say we have a result from a function which is tuple OK, all is well string. And we use control flow structure case, where basically we are pattern matching different clauses and acting accordingly. So this one here, we feed it to the case. It doesn't match this one. It will match this one, and it will output all is well to standard output. If there would have been another tuple, let's say error, reason, tuple, it would go here. If nothing matches, it will throw an error. Another control flow method called condition, which tries to match different conditions to see which of them is true, and based on this executes code. This is kind of like similar to else if structure in imperative languages. This isn't actually used that much in Elixir, or actually at least I haven't used it too much. And of course, yeah, we have a if statement, so which is cool. In Elixir, named functions are grouped into modules. So named functions cannot exist outside a module. And they are identified based on their name and their arity, arity being the number of arguments in the function. So this function is sum, a name is sum and its arity is 2. So if there would be a function with a similar name but with 3 arguments, it would be in practice a different function. And this is how you call a function in a module. And you can probably see that there is no return statements in Elixir. So basically the result of the last operation is returned from the function. Like said today already, many times in this language as well, functions are first-class citizens. There are anonymous functions, named functions, and functions in Elixir support pattern matching and guard statements. I will show examples. Actually, I will show examples of the pattern matching in the next slide, but anyways, yeah. Here is the example of an anonymous function, how it's defined. So you can define a function, assign it to a variable, and this is how you then call. So you need this dot notation there, so you can call the anonymous function that's assigned to a variable. There's this ampersand character here is used for capturing, function capturing. So we can take from the previous slide the math module's sum function with arity 2. We can assign that to a variable. And yeah, like said, they are first-class citizens, so I can return them from a function and store them into a list or whatever, and then call them when I want to. This is kind of a bit ugly syntax in Elixir terms, but this is just a shorthand using the ampersand or this function capturing for creating functions. So this is basically creating a function with 2 arguments that it's adding both arguments to each other. So this is kind of the shortest way of.
Isn't this division by 2, SSID division, meant that
this?
Values, yeah, the result of the previous function should be divided by 2.
No. This means the. Yeah. This is the arity. Yeah. That's very good point. Yeah. So this. Yeah. So basically, yeah, since I mentioned that the functions are defined by the name and the arity, so basically math module could have another function with the name sum, but different arity, so we need to tell it which function we want. Yeah, it's a division. Yeah.
So it also have default, for example, if there is only one?
No.
You don't need to specify that?
No, you need to specify. You need to specify. The name and the arity always when you are referring to. Sorry?
Matching is per content?
Yeah, I will show the pattern matching for the functions then. But this is basically just pointing to this function. It doesn't have yet anything to do with the pattern matching. Here's the pattern matching in the case of functions. I think we saw pretty much the similar example in some Haskell presentation earlier this morning. So here's we have a module factorial. It has this has only one function. So this is a function factorial of with one arity 1 because it has only one argument. But yeah, it has two definitions, which basically means that now we have a pattern match here. So the first definition matches only when the argument is 0. And when we're calculating factorial, that's kind of by definition, we return 1. And then if it's anything else than 0, it will pattern match here. Of course, the pattern matches can be a lot more complex than this one, but I'm kind of showing the simplest example here. And then it calls itself recursively. And this is how we can simply calculate factorial. You might notice that this call is not kind of tail call optimized, so you wouldn't actually want to do it this way. But this is kind of the simplest example of how you do recursion. And here's an example factorial. How you call this module like this. It should return 120, and it should be a factorial of 5. Yeah, let's say if we would optimize this one so that it's tail call optimized, we should kind of add an accumulator here and pass that. It doesn't become too much more complex, but it's kind of easier here to see how this pattern matching goes. But I would add one more argument here. That's the accumulator where we kind of pass on the argument so that we don't have to call this, because that's kind of the part that makes this not tail call optimized. So it would be a stack overflow at some point if there's lots of a big number. And you might notice that if I wouldn't given that a negative number, it would have still matched here, because this doesn't care as long as it's different than 0. And if I would add, if I would give this argument a negative value, what would happen? It would end up in an endless recursion, because it starts to, there we have a negative number, and it will just never get to 0, which would be kind of the one that exits the loop.
That doesn't mean that integer overflow is on a low. I mean, if you give 0, it will overflow the integer overflow.
No. Stack overflow, because it will be kind of calling itself all the time, because and it's not.
No, it can make big enough stacks. You just need
Yeah, but you can by tail call optimization you can make it work so that it doesn't matter how big number you have. It will all because it will not kind of it will not cause stack overflow. But yeah, kind of tail call optimization is something that's very common in functional languages, because we have these loops kind of always have to be implemented using recursion, and recursion easily ends up in kind of a situation where you get stack overflow. Yeah, and Erlang VM supports a tail call optimization, so in that way we're safe. But you can always write your code so that it won't be optimized. Gee, we have to speed up a bit. Okay, so here's the card statement. So now I would, if I would give it a negative value, I can give these kind of card statements. Here, okay, we need n to be bigger than 0, and this will then only match in that case, and otherwise we are returning errors. So this is what I like about Elixir. It's kind of a really declarative in a way. Okay, so more about recursion. Here's an implementation of map function for a list, and this one is tail call optimized. And we are using the head tail operator here, and here we have this pattern match for the empty list, which should be the case where if we give it an empty list as an argument, so we just return an empty list back. Otherwise, we call recursively the function that's given as an argument to it, and it's implementation of map. So this one gives it an enumerable function that multiplies this by 2, and the result is every element in the list multiplied by 2. Elixir supports protocols, or I meant to say Elixir support polymorphism via protocols. By far the most used one is the Enumerable Protocol. Other ones implemented are string, chars, inspect, and collectible protocols. And what are these protocols actually? So Enumerable Protocol, it means that this function is enum map is a polymorphic function, so I can give it any data type and it will be able to do the map operation on it. So here's as an example, I've said there's a list range and a map given to the same function. And how Elixir does this, I will show an example of an inspect protocol. So we are able to define protocols. So we can implement polymorphism, and this inspect protocol here says that the data type implementing this protocol should implement function inspect. And here is then the protocol implementation for type process ID. And this is actually really cool feature in Elixir. I will show another example of it still. In Elixir we have also structs, which kind of resemble classes, but are not really. They are just underneath. They are just maps which are kind of tagged like this. This struct here is a user struct with default values John, and I can use them this way. Now structs work with protocols. So if I would want to implement this inspect protocol for the user, all I would need to do is define the implementation for the protocol, and this will basically print out when I call inspect. It will print out this here. So this is a really handy way of doing polymorphism. Immutable data is something that's kind of very inherent in Elixir, or it doesn't have mutable data. Functions are used to transform the data, and this is an example of where you usually end up. So let's see, I have a range of numbers from 1 to 100. I want to map them, and then I want to filter them. And this kind of, the more operations I want to do the data, it basically just adds more lines, and the code is not that readable anymore. For this, there's a pipe operator, which is, I think Haskell has similar. I guess it's in F# as well, and we can do the same code as in this previous slide. That we can do simply by this, and it becomes a lot more readable, and it's really handy. So this pipe operator basically means that to pass the result of the previous operation as the argument, as the first argument of the second operation. I think I'll skip these because we are kind of running out of time. There are a few examples of kind of like nested data structures, and because they are immutable, it kind of gets hairy working with them. But Elixir provides some of these helpful macros for dealing with them. These are kind of similar to, I guess, Clojure has something similar. Okay, we get to concurrency. So Elixir has been, or the VM underneath Elixir has been designed from the core for building soft real-time systems. It uses message passing concurrency and the actor model. So we have tons of lightweight processes that are talking with each other with messages. The VM does preemptive scheduling and has parallel garbage collector. And so basically every process is garbage collected separately. So it keeps the system very responsive because it's kind of, it's not your stop the world garbage collector. Here is how you create processes. Very simple way. So we have a function that's in a receive loop. So this means that I'm receiving a message with atom hello. This is again pattern match. I spawn this process by giving this function to the method spawn. I get process ID back. And then I can start sending messages to this process ID. And if I send it hello, it will print out hello. That's actually pretty cool to play with the interactive Elixir console, spawning processes and sending messages to them. There's a quick note on what the process info looks like. I'm not going to detail because we're running out of time. There are some really handy helpers in Elixir implemented for running different kind of concurrent operations. One of them is task, and this API is very similar to the one with C#. So you have a synchronous task, you pass it a function, and this will spawn a process, start processing this task. While it's doing its stuff, you can do some other work, and then at some point start waiting for the result of that task. And this is kind of, you can do a very simple concurrency like this. This is kind of just like a helper to do simple stuff. Elixir also has agents, similar concept to the one I think in Closure. Agent is kind of a simple way to implement shared state. It starts a process with state, and it provides methods for updating this state and fetching that state. And everything is synchronized via this message passing concurrency. So different processes can access this state by sending messages to this agent. And now we get to the fault tolerance. Do we have time still? I think. Like mentioned many times, Elixir runs on Erlang virtual machine. This is my favorite quote about Erlang. It tells it all. Few languages have the mystique of Erlang, the concurrency language that makes hard things easy and easy things hard. By Bruce Tate from his book 7 Programming Languages in 7 Weeks. That's definitely true, and kind of the good thing about Elixir is that you get kind of the hard things easy part with Elixir, and then Elixir actually makes the easy things easy again. Elixir compiles to Beam, so Erlang VM bytecode. There's no conversion cost for calling Erlang code from Elixir and vice versa. And for this reason, Elixir ecosystem kind of uses a lot of stuff from Erlang. Many components in Elixir programs are actually Erlang libraries. When you start looking at Elixir, you will definitely see this term, OTP, Open Telecom Platform. Forget it completely, the name. It doesn't have much to do with Telecom, actually. It's just been named kind of the historical name. But yeah, it's a really good framework for building distributed fault-tolerant applications. So it does a lot of the hard parts for you. And Elixir gets all that for free. How much time we have? A few minutes. I'll probably skip the OTP part. You can get the slides from somewhere later. But that's the fault tolerance is the kind of the thing that gets implemented using the Open Telephony platform. This is kind of the idea behind. We cannot catch all the bugs anyways, so we kind of try to avoid defensive programming, where we try to catch all different errors, and it's better to fail fast and let it crash. That's kind of the mentality here. Then we have supervisors that can be configured to restarting our system once it crashes. We don't have much time, so I'm skipping lots of stuff. I mentioned already about the Elixir Toolchain. It's really good. There's a tool called Mix that does a lot of things. You can start a new Elixir project using Mix. You can create a project with a nice supervisor template. You don't have to write those on your own by giving it this argument. Compiling, getting dependencies, all works really smoothly and fast, and compiling project. Mix gives tools for unit testing, building documentation, uploading packets and stuff also. I have to mention Phoenix web framework. It's kind of built alongside Elixir. It's a full web framework for building kind of modern web apps, because the real advantage that we get from Elixir is the concurrency and its kind of ability to handle lots of simultaneous connections, for example. So Phoenix has this kind of special feature compared to other web frameworks. It implements channels, which are WebSocket connections, real-time connections that you're able to publish and subscribe data. It has implementations for browsers and native mobile apps and embedded devices. It's really good. It's really cool. Take a look at it. Here's a quick tweet flow from guys benchmarking Phoenix, starting with 128,000 concurrent connections on a single node. Next tweet, a few days later, 330,000 connections. Now we fixed the bug. We have 450,000 connected clients on a single box, and end up in 2 million concurrent connections with a responsive system on a single, 40-core, 128 gigabyte box. But still, really impressive. Yeah, those are connected sockets, and you are able to push data in them. So 2 million on a single box. They were actually using something like 45 machines to create load for this one single Phoenix box, because it's actually quite difficult to create client connections. So I'm not in any way affiliated, but these are really good books. Programming Elixir and Metaprogramming Elixir by pragmatic programmers. If you read these two, you know everything you need. There's a book about Phoenix framework as well. Thank you.